Okay, today we're going to talk about laws of exponents. And just to recap, they must have the same base. They must be the same base. So I'm going to recap here all of the parts of an exponential expression. So you've got your superscript of 2, that would be your exponent. Your base is x in this expression. X is being raised to the power of 2. And then 3 is your coefficient. Your coefficient tells you how many of your bases and exponents that you have. So I really have 3 of the x squared terms. Now, it's important to note that your coefficients and bases are going to follow different operations. It's called the law of exponents, not the law of coefficients. So your exponents will always be doing or performing a different operation than your coefficients. So for example, for product of powers, you're going to add your exponents, but you're going to multiply the coefficients because we are taking the product, and product is telling me to multiply. Okay, so let's look at our example here. I've got 2 times x to the power of 2 times y to the power of 3. All of that being multiplied by 6 times x to the power of 4 times y. So we are going to multiply our coefficients, 2 and 6, to get 12. Now I'm going to look at my next like base. I have x squared times x to the 4th. Those are like bases, so I'm going to add the exponents. So I'm going to add 2 and 4, and I'm going to get x to the power of 6. And now I'm going to look at my y's. Those are my like bases, so I've got y to the 3rd times y. There's one of them. It's an invisible exponent of 1. So I've really got 3 plus 1 because I have to add the exponents. So I've got y to the 4th power. Now look at quotient of powers. So quotient tells me that I'm going to be dividing, but that's only for my coefficients. My exponents are going to need to be subtracted. Okay, so now I'm going to look at my coefficients. So I've got 3 divided by 12 because it's a fraction, so it's telling me to divide. So 3 divided by 12, and I'm going to make this a fraction, so I'm going to say math, 1 enter. So that would be 1/4. Now I'm going to look at my next like base. So I've got an a in the numerator, but I don't have an a in the denominator. So nothing is going to be subtracted away from that exponent of 5. So I'm just going to copy down my a to the 5th power right there beside my 1/4. And now I'm going to look at my final base of b. So I've got b to the 1st power divided by b to the 3rd power. So I'm going to subtract my exponents, and how I'm going to subtract them is I'm always going to take the top exponent minus the bottom exponent. And now I'm going to have b to the power of -2. Now, this is where our negative exponent law or rule comes in because we don't want our exponents to be negative. So what we're going to do is we're going to move only the base that has the negative exponent to the other side of the fraction. So I'm looking here. The only base that is raised to a negative exponent is the b, and I am going to move that to the bottom of the fraction because right now it's technically over 1, so it's in a numerator. So I'm going to move it to the denominator to be with the 4 in the 1/4. So my final answer is going to be 4 times b squared in the denominator. And notice when I move that b raised to the power of 2, that exponent, when I moved it, changed to a positive, which is what I want. I want my final answer to have all positive exponents. And now I'm left with, in my numerator, an invisible 1. I don't have to write that 1, but now that a to the 5th is going to stay in the numerator because it's like a to the 5th all over 1. So it's in a numerator, and it's going to stay. So there's my final answer. Power of a power. So power of a power is telling me that I'm raising my coefficients to a power and my exponents are going to be multiplied. So I've got 3 times b to the power of 2. All of that raised to a power of 3. So I'm going to raise my 3 to the power of 3. So my calculator, I'm going to say 3 to the power of 3. I'm going to hit enter, and that's going to be 27 because that's like 3 times 3 times 3, 3 to a power of 3. And I'm going to get 27. And now I've got b squared, or b to the power of 2, raised to another power of 3, so I have to multiply my exponents. Well, 2 times 3 is 6, so that is going to make b to the power of 6. And that is going to be my final answer because I have no negative exponents. So now we're going to skip down here to the negative exponent. So we're going to look at our base that is raised to a negative exponent, and that is the only one that's going to move to another side of the fraction. Well, if you look at your problem here, the only base that's raised to a negative exponent is your r base. And since it's in the numerator, the only place it has to move is the denominator. So it's going to move down into the denominator to be with the s. So my final answer is going to be 6 is going to remain in the numerator, and the r to the power of 2, because I want that negative exponent to change to a positive exponent, and it's going to join the s. Now when you have two variables together, either in the numerator or denominator, it is common practice to write them in alphabetical order. That's why I put the r to the power of 2 before the s. And that's our final answer. So now we're going to look at rational exponents, and this is a law that I didn't really touch on because I don't see it very often in Algebra 1. But if you happen to have an exponent or a base being raised to a fraction exponent, here's how you can change it to write it as a square root. What you would do is your numerator in the exponent is going to become your exponent inside. So you see how this m was in the numerator, and then you write your base to the power of your numerator. And then your denominator simply becomes the index outside the square root. So let's see if we can take this really simple example and do that. So my numerator, so I'm going to write my square root, and I'm going to write my base of a because my base won't change. And now I'm going to write my numerator as my exponent on my base. So it's going to be an exponent of 1. And my denominator is going to become my index, so 2. And we all know that our index of 2 is kind of like an invisible 1, so we would not see that on a multiple choice test. All right, so now we're going to look at our example. So here we have 3 times x raised to the power of 1/2 times 4 times x raised to the power of 1/3. So what we're going to do is, since we are multiplying, that goes to our product rule, which means we're going to add our exponents and multiply our coefficients. So 3 times 4 is going to be 12. And now I've got a like base of x, and I'm going to add their exponents. So since I have fractional exponents, I'm going to type in 1/2 plus 1/3, and that's going to give me a new exponent of 5/6. So it's going to be x to the power of 5/6. Now, if I wanted to use my rational exponent law where I rewrite it with a square root, I'm going to write it like this. So I'm going to have a square root, and I'm going to keep my base. My base is x. I'm only worrying about this x. I'll deal with this 12 in a second. So now I'm going to write my numerator as the exponent on my base. So my numerator is a 5, so my exponent becomes a 5. And my index comes from the denominator in that fractional exponent. So my index is a 6. And then guess what? Since we're multiplying by 12, all of this, the 6th root of x to the 5th power, is x to the 5th 6th power, 5/6 power. So it's just going to be multiplied out front. So it's just going to come out here in front of all of that square root. Now you could see either of those answers. Just know that those are, it's kind of like writing 1/2 and 0.5. Same numbers, just written a little differently. All right, example 2. If I see a fraction bar, that's going to cause me to think that we are going to be taking the quotient, we're dividing, so that means my exponents will be doing a different operation or performing a different operation. So I'm going to look at, I have no multiplication in my numerator denominator, so I'm going to go straight to dividing my coefficients. So I've got 5/10, and when I divide 5 by 10, top divided by the bottom, I'm going to get 1/2. I'm going to go ahead and write that as a fraction in case I have to move any negative exponents. All right, my next like base is going to be x to the 3rd and x to the power of -2. So I'm going to say top exponent, subtract, and then I'm going to type in the bottom exponent. And notice I did not use this negative as the subtraction sign. It got its own negative symbol on the 2. When you have 3 and you take away a -2, you are going to end up with a power of 5 on your x. And now I'm going to look at my next base, which is y. And notice I have no y in the denominator, so I'm just going to copy that down, y to the power of -2. And now I'm going to look at my z, I have z to the power of 1 divided by z to the power of 2. So I'm going to say top exponent minus the bottom exponent, and that's going to leave me with z to the power of negative 1. All right, so now we have negative exponents that we're going to have to take care of. So the base of y is raised to a negative 2 power, so that's going to move to the denominator. And my power of z is also raised to a negative exponent, so that's going to move and become in the denominator. So we're going to clean this up a little bit. So we're going to have our fraction bar. My 2 is going to be in the denominator. My y, and when I move that y down, that negative 2 is going to change to a positive 2, and now I'm going to have z. And that negative 1 is going to change to a positive 1, but since it's a positive 1, I don't have to show that exponent. So 2y squared z is my new denominator, and now I'm going to fill in my numerator. Well, I'm going to have a 1, which I don't have to show unless it's the only thing in the numerator. And then this x to the positive power of 5, it's not moving anywhere, so it's just going to stay in the numerator, because you can think of this as x to the 5th power all over 1. And there's your final answer. All right, example 3. It looks like we've got a power being raised to another power, and we don't have any coefficients to worry about, so now we're just going to simply multiply our exponents. So I've got 1/3 times 3, and that's going to be 1. So I have x to the power of 1, which as a final answer, I would simply write it as just x, because they're not going to show you that exponent of 1. It's going to be invisible. And now we have a word problem. So we have a square has a side length of 5x squared y. The area of the square can be found by using a equals s squared. What is the area of the square? Well, here's my square. So I'm kind of drawing a visual picture here. So if we remember any of our traits from a square, we know that the side lengths are the same. And to find the area, I would just take length times width. So I'm going to have 5x squared y times 5x squared y to find the area. So I'm multiplying. This is product. So now I'm going to multiply my coefficients because they follow the same operation. And that's going to be 25. However, my exponents are going to follow a different operation, and they're going to be performing addition. So now I'm going to look at my next base. I have an x squared times an x squared. So I'm going to add those exponents. 2 plus 2 is 4, so it's going to be x to the 4th power. And now I'm going to look at my next like base. I have a y times another y. So those are both to the power of 1. So I'm going to add 1 plus 1, which is going to be 2. So I'm going to have y squared. And that's my final answer. All right, now you can look at your benchmark questions over laws of exponents.